An example of an entity resolution use case is the matching of entities from two sources. For example, the Refinitiv Perm ID dataset and entities from the global LEI dataset. We performed matching of entities between these datasets using deterministic rules. For those entity matches which were of low confidence, these went into manual review. We estimated it could take up to 1 minute for a reviewer to manually determine whether or not these entities were a match or not. And that's fine whenever you have a few entities that you want to manually check, but whenever you have hundreds, thousands, or many thousands of entities which you need to check, you can see how this escalates the time required to do this and also the resource required to do this. So this makes a perfect example of where machine learning can be applied and add value to the process. So in machine learning, the algorithm, what we can do is that we can feed that algorithm examples of matches and non-matches. And this algorithm will gradually learn to detect the patterns within that data. We can then use these patterns to make predictions on new unseen cases. And a reviewer can also validate the predictions that the machine model has made. And all this information is then fed back into the algorithm again. This is known as human-in-the-loop machine learning, and you will reach a stage whereby the algorithm continually improves in its accuracy and it becomes smarter in its predictions, so that high quality predictions can then alleviate a lot of the manual review process by reducing the volume that needs to be reviewed. In summary, these are some of the lessons that we have learned through our entity resolution use case. Firstly, by applying machine learning, we can augment the traditional rules-based approach and build in that explainability and transparency into the process. We're also able to provide high confidence predictions to a number of tasks and automating those tasks. And this is very useful to speed up that review process and enable people to do more with their time. And finally, that we have highlighted that the models that we have built need good quality data in order to make predictions from. And from that, we've been able to use our existing tools in Flow Designer, Data Quality Clinic, Data Quality Manager in order to manage that process. So we're able to curate good quality training sets, and we're able to apply labels to those data then as well. So next steps in terms of machine learning and Datactics is to further enhance the Datactics platform and augment with machine learning capability. So that is, for example, providing that human-in-the-loop machine learning to provide prompts and suggestions to users for tasks, to further research and develop automated data discovery and rule extraction, to look at graph linkage analysis, and further enhance our feature engineering and dataset labeling capabilities. To learn more about the work that we're doing with machine learning and how we're applying it within the Datactics platform, all content is available on the Datactics website. Up on this site we have our AI blog series, which covers areas such as AI ethics, AI explainability and monitoring. We also have our white paper on AI augmented data quality and webinars which highlights the entity resolution process augmented with machine learning.